Hi, hello everyone. Welcome back to our channel. So for today, I am going to discuss to you about functions. Functions are basically used in algebra, physics, chemistry, calculus, and pretty much in any advanced learning mathematical concept that you will get. It will always involve function. So for today, we will go a little deeper to what a function is, illustrate it for you, and give you some basic example of a very common functions that we see as we get into advanced learning in algebra. So, are you ready? Okay, so listen attentively so that you will understand better. In many situations in science, business, and mathematics, there exists a correspondence between two sets. The notion of correspondence occurs frequently in everyday life. For example, to each human being, there corresponds a birth date. Okay, so individually, us as a human, we have our individual birth date. Number 3, to each room in a hotel, there corresponds a room number. So with this example, a function is a correspondence or a mapping between two sets. So we have x and y, in which each element in the set x has a corresponding value for element y. For example, these x are now the room numbers in the hotel. And each room in the hotel, these are the number of persons inside the hotel. So each element in the x, there corresponds a value of y. Wherein, these elements for set x, we call this the domain. And for the elements for y, these elements, we call it the range. Okay? So again, for the elements of x, first elements, we call it the domain. And for the second element, for the values of y, we call it the range. Moving on, let us have more examples. Say for example, the amount of tax a company pays depends upon its profit for the year. So is the situation a function? Yes, because all taxpayers pay their annual tax based on their income. Did you get it? Alright, let us have another one. For every vehicle, there are 2 plate numbers issued. Is the situation a function? No. Since each vehicle has one and only one plate number. So did you get the difference between function and not function? We can only call the situation a function if each element in the set X there corresponds an exactly one value in the set Y. So did you get that? Let's proceed. To denote functional relationship between two variables x and y, we will use the equation f of x is equal to mx plus b, right? Or in your lower grades, in your junior high school, we call that as y is equal to mx plus b. So meaning, f of x is just equal to y. They're just the same. But since we are talking about higher mathematics and we are now dealing with functions, that is why we have f of x is equal to mx plus b. A function in algebra is a mathematical, or I want to call it for you a machine, that it takes x values as the input to the machine and it takes out y values or the output, and we call it f of x as the output values or the y values in a one-to-one correspondence. Each value of x that is used as an input to the machine has its corresponding value as y values. So let us have an example. For the function, using the function f of x is equal to mx plus b. So given the function f of x is equal to 2x plus 3, find f of 2 and f of negative 5. So this time, this f of x that is equal to 2x plus 3 is now the machine. That if we are going to input something to the machine, there will be an output which is the value of y or f of x or function of x, right? So find f of 2. So this f of x now will become f of 2. So f of 2 is equal to, we will substitute now x with the value of 2. So 2 times the value of x, substitute 2, copy, plus 3. 2 times 2, that is 4, plus 3. Our f of 2 now, or the values of y, is 7. The value of y now, or we call it the range. The range now is 7, and the domain is 2. Did you get it? Let us say, what about f of negative 5? So, if that will be f of negative 5, using this function, the value of x is negative 5, okay, plus 3, 2 times negative 5 is equal to negative 10 plus 3. So our f of negative 5 now will be negative 7. Did you get it? So here, our domain is negative 5 and our range is negative 7. Let's have another function. Given the function f of x is equal to x squared minus 2x plus 1. Let us have another example. Given the function f of x is equal to x squared minus 2x plus 1, find f of negative 3 and f of 4. So first, we are going to substitute x with negative 3. So this will be our first input, first value of x, or the domain. We will now substitute this one to the given function. So our x will become negative 3 squared minus, copy, negative 2, the value of x, substitute it by negative 3, plus 1, copy, there, simplify, negative 3 times negative 3 will become positive 9. Negative 2 times negative 3, it will give us positive 6. Copy 1, so plus 1. So 9 plus 6 plus 1 will give you positive 16. So our f of negative 3 is equal to 16. Okay? What about f of 4? So instead of x, you are going to write f of 4. So f of 4 is equal to, the value of x now will become 4. So that will become 4 squared. 4 squared minus 2 times our value of x. Substitute it by 4 plus 1. Alright. Simplifying further, 4 squared will give you 16. Negative 2 times 4 will give you negative 8. Plus 1 will give you positive 9. So our f of 4 is equal to 9. Your domain is 4 and your range is 9. Did you get it? I hope you do. Now let's proceed on operations of functions. Composing two or more functions will also result into another function. So let us have more examples. So we have this pattern for operations of functions. Say for examples, we have the two functions f of x and h of x. Then we can add the two functions. So if we have for letter A, for addition of functions, f plus h of x, so we can add them. We will add the first function, f of x, to the second function, h of x. Alright. For the difference of functions, f minus h of x, then therefore, we will subtract the two functions. We have f of x minus the second function, h of x. We can also get the product of the two functions. Say for example, if we have f times h of x, then it will result into f of x times the second function, h of x. We can also divide functions that if the divisor or the denominator is not equal to 0. Since any rational expression, if the denominator is 0, that will be undefined. Now, for this one, two functions, f divided by h of x, so you can have the first function divided by the second function, h of x. We also have composite functions. So if you have this one, this is not product. This is f circle h, or it means f composition of h. And we can simplify this one by simplifying first, substituting first the value of x to the nearest function before we will evaluate this one to the next function. Later, you will understand that fully as I am going to discuss to you further. So we will start it with the operations of functions first. Let me give you an example. So given the functions f of x that is equal to 2x squared plus 2 and h of x is equal to x plus 1, we will now evaluate these two functions applying the four operations in mathematics. We will start off with addition, then subtraction, then get the product, and then we will get the quotient, and then also the composition of functions. For the first operation, we'll have addition. Given the two functions, f of x is equal to 2x squared plus 2 and h of x is equal to x plus 1, then we can add the two functions. So we have the pattern f plus h of x. That will be result into f of x plus h of x. We will now substitute this f of x by 2x squared plus 2. And this h of x, we are going to substitute this one by x plus 1. Right. So the value now of f of x is equal to 2x squared plus 2 plus, copy this one because we are adding two functions. Our h of x, the value is x plus 1. X plus 1. What shall we do next? We are going to combine like terms. So since there are no other terms that are alike to 2x and also x, we will just simply copy it back. So 2x squared, copy x, plus x, combine 2 and 1, 2 plus 1 will give us 3. So our f plus h of x is now equal to 2x squared plus x plus 3. Do you follow? Next is the subtraction of two functions. Given the two functions, we can also subtract the two functions. So, with our pattern f minus h of x, it may result into f of x minus h of x. Now, substituting the value of f of x by 2x squared plus 2, again, 2x squared plus 2 minus the value of our h of x, which is x plus 1. We will put that inside the parentheses since our operation here is subtraction. So we have x plus 1. So as you can see, there is a subtraction operation here. So all you have to do is to distribute the sign to each term inside the parentheses. Now that will give us 2x squared plus 2 negative times x will give us negative x. Negative times positive 1 will give us negative 1. Simplifying further, that will give us 2x squared, copy negative x since there are no other terms that are alike, so negative x combine 2 and negative 1 will give us positive 1. Okay, so f minus h of x, the result is 2x squared minus x plus 1. Do you follow? Okay, let's proceed on product of two functions. Given the two functions, 2x squared plus 2 and x plus 1, we can get their product using this pattern. F minus h of x is equal to f of x, this function times this function. Substitute now. So our h of x is 2x squared plus 2. 2x squared plus 2 times the second function, x plus 1. So we can now get the product of these two functions applying FOIL method, or getting the product of the first term, outside term, inner term, last term, and then simplifying will result into the final answer. Alright, so for the first term, 2x squared times x will give us 2x cubed. Then the outer terms, 2x squared times 1 will give us 2x squared. Then the inner terms, 2 times x will give us 2x. Then the last terms, 2 times 1 will give us 2. Simplifying further, so since there are no terms that are alike, this will be now the final answer of f times h of x. The result is 2x cubed plus 2x squared plus 2x plus 2. What about getting the quotient of the two functions? As I have said earlier, we can only get the quotient of the two functions if the denominator or the divisor, the value rather of the divisor is not equal to 0. So as you can see, our divisor is x plus 1 and it is not equal to 0. So we can now determine their quotient. So substituting the value of f of x as 2x squared plus 2 divided by h of x, which is x plus 1. We will try to simplify the numerator. As you can see, you can factor out 2. So 2 times x squared plus 1 all over x plus 1. So even if we factored out the numerator, as you can see, there are no terms that can be divided out. So if we are going to divide the two functions f of x and h of x, the result is this one, or just this one. Okay? There are no terms that can be divided out. Right? So we are done with the 4 operations. We'll now proceed on the composition or the composite functions. So given the 2 functions, we can now determine the composition of these 2 functions following this pattern. We read this one as F circle H, or F composition of H. This may result into F of H of X. Alright? So for the composition of functions, we are going, if for example, we are going to simplify F composition of H of 2. To simplify composition of functions, look for a function that is closer to the given possible value. So in our given, 2 is much closer to H of X than that of F of X. So first, we are going to evaluate first H of 2, and after that, the answer for this one, we will substitute it to the first function. So we need to evaluate H of 2 first. So our function of H of X, our H of X is equal to X plus 1. So we need to find the value of H of 2. So H of 2 now, substitute X by 2. So our X here will become 2 plus 1. Then our H of 2 is equal to 3. So after evaluating H of X first, because H of X is much closer to the value, to the given value, then this one now, the value of H of 2, which is 3, shall be substituted to the given function F of X. So to continue, our F of X now, our F of X is equal to 2x squared plus 2. Our H of 2 is 3. We will now substitute X by 3. So this F of X will become F of 3. So substituting X with 3, 2 times 3 squared plus 2. This will give us 3 times 3 is 9 times 2 will give us 18 plus 2 will give us 20. So our F composition of H of X, or rather of 2, is equal to 20. I hope you get that. So again, to solve for the composition of functions, you have to look for the function that is closer to the given value in order for you to simplify or evaluate. We have to evaluate first this function that is closer to the given value, right? Then after that, you are going to substitute the result to the next function. And then voila, you have there the F composition of H of 2. I hope you learned something from me today. If you have some questions, kindly comment down at the comment box below. And if you haven't subscribed to our channel yet, click subscribe and click that notification bell for you to be updated with our videos. Thank you so much for listening. Bye-bye.